in other platforms or maybe in the future. So this is a jamming session. I was thinking about the following agenda. I thought about last time we did like a very high level review of the code, of the concept of our MOA design. And I thought this time we could maybe go a little deeper. I'll show you some code, show some of our Cairo code, and show you some for specifically we use we obviously write our contracts in Cairo, and we use Python for some of our end-to-end tests. But so maybe I'll show a little bit about how we interact with the contract. And then maybe we can have a few, if anyone has any questions or they want to discuss something, that would be a great time. So let me share my screen now. What I'll be showing is a work in progress, right? It's not fully settled. It's still changing. So there could be a few changes here and there, some parameters changing. Right. So I'm looking. I opened up our code. Specifically our MOA contract, our account, MOA account. And what I wanted to start with is actually the constructor of this account. So when you initiate this account, you call the constructor. When you deploy, we will eventually, once things are a little settled, tomorrow, sometimes this week, we will have some class hash you guys can use. And when you deploy it, you will need to give it the following parameters. So you need to give it a list, an array of signers, and you would need to give it a threshold. So the meaning of threshold is, how many signers need to sign off on a transaction before it is sent out. And signers is the list of all legitimate signers related to this account. And this list has, it's a list of tuples, and this tuple is, as you can see here, it's a tuple of contract addresses. So all the different signer accounts and the public keys. So the second felt here is the public key. And we will eventually use that to check, validate the preamble. Okay. Now, so this is the constructor. So again, it's pretty straightforward. It receives the list of signers and the threshold that we need to sign off on. Now, let's say we deployed the account. We have this MOA contract out there, and we have a list. Let's say we got 5 signers. We got the threshold of 3, and the question is, what's going to happen next? How can we move on from this spot? So there are several flows we can go. So the first flow is, of course, someone needs to propose a transaction to execute. So maybe we need to upgrade one of maybe we're a dev team and we need to upgrade some account, or maybe we just need to transfer some funds around. So the first proposal, like the first person who wants to run a transaction, we call them proposers. And the way they do this is they construct a special transaction that is in fact a multi-call, where the first call in this multi-call is a call to a function called assert max fee. So the exact functionality here may change a little bit, but we put the first call must be assert max fee, and we actually validate this in our contract. And the rest of the calls are arbitrary, like whatever you want, transfers, upgrades, any call is okay. But when you propose transactions, you must have assert max fee as the first transaction. And the reason we do this is because we want the first person who signs on a suggested transaction, we want him to set boundaries for fee spending. So they want to upgrade their account, and they want and they have to state how much fee they're willing to pay. So let's say 1 ETH is the upper limit, and the rest of the signers, when they want to sign the pending transactions, they will also see this higher bound of fee spending. So they will see, okay, we got this transaction where we are about to upgrade some contract, and the max fee set on that transaction will be 1 ETH. And this is important because there are a lot of very delicate and intricate issues with MOA accounts, because you must take into account malicious actors in your MOA settings. So maybe you got 1 or 2 or more malicious signers that got the seed phrase somehow. And malicious signers can do a lot of things. Specifically, we have MOA to prevent them from just signing off on whatever transaction they want, but maybe they can do other things, like maybe run transactions with very high fees and drain the account. So that's not ideal. And that's why the first person who proposes the transaction also proposes a max fee. And all the other people who want to sign on that will agree on that fee. And there are a few delicate spots here. So the specific signature might change a little bit, but we must have this to protect the MOA account. So at least this is our approach to this problem. So yeah. Nestor, you want to speak, to ask a question?
Sure.
Yeah.
Hi, Mar. Quick question there. In this context, how we should think on how can we use a MOA in order to deploy the smart contracts? Because right now I've been looking into Starknet Foundry, also Starkly, but of course you need to sign something before doing that. But how can we declare without signing? How will be that that framework? to say, hey, we are a team and we're gonna have a MOA, and
Yeah.
then from the MOA we are gonna first declare the smart contract and then deploy it. How that will work?
Yeah. So maybe let's see an example here. I was looking for one. Where is that? All right. It's in our utility here. So our end-to-end testing framework generates a bunch of different scenarios that use the MOA account. So this is a pretty simple one where the MOA account wants to, the owners of the MOA account want to transfer some funds somewhere. So specifically, this function returns like a list of uh, a proposal transaction. So if you notice, the multi-call has two calls. So the first call is, like I said, a call to assert max fee with a max fee value. So again, when you propose a transaction, you have to start with assert max fee. And the second one is a transfer. Never mind the details, but it's a transfer of a token out of the account. So let's say we want to declare a new class hash. So you would one user of the account would generate something like this array of calls, but instead of transfer, they would generate a declare call. I'm pretty sure that shouldn't be an issue. So a declare call. And then it depends. So if let's say we need 3 signers, then they would create a signature with all the 3 signers and send a transaction, and it will be executed because it already has all the 3 transactions needed. But let's say if it's maybe a very distributed team, then maybe they would send this 2 calls and sign on it with their private key, which is a part of, since they are a part of the list of users. So that's one signature. And then the other users will make another call, and I'm gonna show it in a second. So it's a great follow-up. So we talked about assert max fee. This is what you have to attach to your transaction. That's what you have to prefix to your transaction whenever you want to propose a new transaction, like declaring something or transferring ETH or whatever. So let's say you did that, you sent a assert max fee and the transaction you would like the MOA to execute eventually. Now, what do the other team members have to do to sign off on that? They will need to call another transaction, which is sign pending multi-sig transaction. And they will need to call this function, send a transaction with a call to this function, and sign off on that with their signature. And once they do that, the count of how many signers have signed off on this transaction goes up by 1. And once we reach the threshold, which is that threshold that we set up on our constructor, then the transaction would immediately execute. So it would take the declare or transfer or whatever we have and execute it once we reach the threshold. So as a user of the MOA, you sort of interact with you need to be familiar with 2 special functions. So it's the assert max fee, which must be a prefix when you propose a new transaction. So it has to be the first call before the rest of the things you want to do, like declaring or deploying or whatever. And then whenever a single signer wants to sign off on that pending transaction, they would call sign pending multisig transaction and sign on it with their signature. And so the question is, how do you sign on this signature? So let me, I think I have it in a comment or something here. Let me find that. Yeah, so just looking for that function. So how does a signature would look like? So a signature, it's a little different than the typical Stark signing signature. You would have your address. You need to put your address as the first felt. And the second one is the public, your public key. And the account would take these two fields, these two values, and would figure out whether you are actually in the list of the original signers. Are you a legitimate signer, which is stored in the account? So that's important. And RNS is the signature using your private key, your Stark private key. So that's the typical signature you send for transactions. So you add that, and the next part, these two values, they are the really special part, because what we're trying to do here is that we say that the preamble signing with your seed phrase, your private key, is not it's not necessarily enough, and you can do arbitrary additional signatures. So the way this is parsed is you give out the signature length, like how arrays are sent. They always start with the length. So you put the length here, and then let's say an arbitrary list of values. So what would be a specific scenario? So let's say you have a Braavos account, and Braavos accounts have that you can set up a hardware signer using your phone, for example, to sign on things. So what you can do, let's say the hardware signer signature is 20 fields or something, then you would put 20 on the signature length field, and then you would put the 20 fields that come after that, whatever your iPhone or Android generated when you signed it with your Face ID or whatever. And once you have that, then what does this account do? It takes this signature and it calls your contract. So it takes your address and calls is valid signature. So according to the SLC 5, I think, which defines accounts, one of the function every account has is valid signature, and it receives just a bunch of bytes, a bunch of fields, and this is being utilized here to verify arbitrary signatures. So so you can have hardware. If you have an hardware signer in your account, then you can just put all the fields of the signature here, and it will be sent to your account for validation for your consumer personal account. So if we take another example, just to make this clearer, let's say we have one hardware signer user and another one that uses a passkey, like the one you have on your laptop when you put your Touch ID, and another third arbitrary mechanism of signatures. Then each and every one of these will have a different, when they send a transaction, they will have a different siglen and the bytes here, and all this information will eventually be sent to isValid signature, and according to the result from that call, we could move on and execute the transaction. So just to maybe recap everything into one single flow, then let's say we need like the previous scenario, we have three transactions, three signers, one hardware, one uses passkey, and another a third exotic signing mechanism. Then the first person, let's say the hardware signer, would generate a transaction with a call to assert max fee as the prefix to the call array. So that would be the first call, and then whatever they want to execute. And the signature that they will attach to this transaction is not going to be the regular Starknet signature. It would be the custom one right here. So they would put their address, they would put the regular Stark public key, the signature, the preamble signature, and then the arbitrary hardware signer signature. After that, the second person, let's say the passkey user, they would make a special transaction to sign pending multi-sig transaction. And the signature to that transaction would be the same one with their address, their public key, but with passkey signature. And eventually the third one would also come online and look at the transaction. They would call this one again and fill out. And when they sign it, they would put this information with their arbitrary signature, which will be validated using the custom isValid signature function. So that is generally the flow. So maybe some functions here would have a little different call data, maybe another parameter here and there, but that is basically the structure. A few caveats worth remembering is that we only allow two modes of operation. So you either have one signature on your transaction, or you have all the signatures required to meet the threshold needs. So it is possible. You don't have to work in a cascading manner where everyone signs one after the other. You could gather up all the signature offline and then just send them all in one transaction, because this signature format that I'm showing here, it's not limited to one address. You can put like 20 signatures here, as much as you like. And if you meet the threshold, then the transaction would immediately execute, and that's great. The other mode is just sending one signature. And if by any chance you reach the threshold, then it will execute, but otherwise it will stay pending. What you can't do is you can't send, let's say the threshold is 5, you can't just send 3 transactions and leave the transaction pending. So that's one of the limitations, just due to some security risk that causes. One more caveat, and then I'll let you ask some questions. The second caveat is, if you notice, when you first the first step is calling assert max fee and proposing your and the rest of the calls you'd like to execute. And whenever someone signs on a pending transaction, they must also attach the calls. So the calls must be shared offline between the members of the team. And of course, the contract validates that you're not sending some arbitrary calls, you're not signing on some garbage. It validates that it is what the original proposal of the transactions had in mind. But other than that, you do need an offline mechanism to share these calls. Otherwise, it would just be, it might be too expensive to save all that information on chain. So in effect, we just save the hash of that. Okay, so Nestor, I think you had a question.
Yeah, more. I think that I understand a little bit on how that will work with uh, uh, instantiation of contracts. I mean, when you have the clash hash and so on and so forth, because you can easily create the transaction. But I'm curious on how do you do without at first. I mean, in order to declare a contract, once we don't even have the class hash uh, at the beginning, how do we create that transactions that then it's gonna be sent to the different signers of that MOA?
If we talk, if we like other transactions like invoke or deploy, do they make more sense on how it would work with this setup?
Sorry?
Let's say you do have a class hash and you just want to deploy a contract or upgrade. Does that, the way that would work makes more sense?
Oh, okay. Yeah, I have thought before that you should have I mean, I was thinking that you should do everything from scratch with a MOA. What I mean is a team create a smart contract, and then they decide, hey, we are gonna deploy we're gonna first declare this smart contract. So then they will need to, sign that object in order to receive the class hash, and
Mm.
then they should create the instance. And for the instance, it's more easy to understand in my view how all this process is going to work. But what you're saying, if I'm correct, please correct me if I'm wrong, is that the declaration should be done from a standard account, and then the instantiation of
Yeah.
of that clash hash should be done with the MOA.
Yeah, I think the MOA is more the MOA is more intended for the maybe the dangerous parts of your workflow, like actually upgrading a live account or transferring funds. if someone declared a class hash, that's great, but are we going to upgrade our DeFi protocol to that class hash is something that the MOA members should agree on.
Got it.
So it's
Okay.
more invoke transactions.
Okay, now that makes more sense. Thank you. And then the following question will be, so if I get it correctly, there are many parts of this workflow. First, of course, the declaration, then you're gonna create the object for the transactions that it's gonna be needed to be signed by all the parties or the threshold of that MOA. But then that request of transaction should be sent somehow to the the users of the members of that MOA, and that should be, I don't know, a UX or a UX that needs to be done for that project, or how are they gonna be sharing that?
So it's a
Yeah.
good question. I'm thinking so our track has two options. I think the most relevant and straightforward one would be interaction with some kind of integration with Starkly or maybe some other tool or Foundry. I'm not sure. But yeah, you would need some kind of mechanism to whatever client you use to add this functionality to sign, propose transactions and sign pending transactions. You would need some kind of mechanism to share the calls between the participants of this account.
Got it. And just as a quick question, there is no risk of security, right, by leaking these transaction requests, right? Because I mean, anyone could have it. That could be public, right? Because you need, the private key in order to sign, and you
Yeah,
need to be part of that MOA, right?
yeah. You must attach a valid signature to that when you sign a pending transaction or whatever. You need to sign off on that list of calls, that transaction, on like all the elements, the call structure, the call data, all of that is being signed on. So you shouldn't. It shouldn't allow any tampering with the.
Mm-hmm. Awesome. And the last one, sorry. How is there any function in this smart contract to pass um to pass my public key, my address of my personal account, and get that any pending transaction?
So a, and more accounts can only have a single pending transaction at any given moment. So there's only one transactions going on. You can doesn't support like parallel
Okay, got
transactions.
it.
Yeah.
And how can I get the last? Oh, well, yeah, I will get the last transaction and just verify if that has been uh completed somehow, right? That should be one field.
Yeah, and also notice that, let's say someone proposed the transaction and it is just hanging in out there, no one is signing it. It is possible to propose another one, and that would override the previous transaction. Uh,
Hmm, interesting. Okay.
And yeah, I think there's a view function that brings back the transaction hash, if I'm not mistaken.
Got it. So in the meantime, right now we should just wait, right? Because if I'm not wrong, you're gonna pu push these changes in the following days, and then you are gonna, you know, declare the contract, and then with the hash is the one that, you know, we're gonna be using to hack on, right?
Yeah, I think maybe I'm hoping by tomorrow we'll have some class hash out there on Go Early that can be used. Not it's not necessarily the final version, but something.
Yeah, sure.
And then you could start playing around with it, maybe deploy it with other contracts, deploy it with a few signers, and see how that works. And I'll be also happy to hear about any teams forming and what projects they thought they would work on. Just hear a little bit more detail on that.
Awesome. Yeah, just a chat about me. Yeah, really, I'm really interested into the MOA account and how to make it more like a uh action
Okay.
uh and yeah, integrate that in a very easy flow and very easy and very secure flow. Like, hey, we are a team and we want to deploy this new version of create a new version of the smart contract, and then how can we do it in a safe way and with a MOA? That would be my goal.
All right. So I'll I'll send a message over on I think Discord, and once it's done, once it's ready, and maybe then we can interact specifically with you and go deeper into what you're trying to build, and
All right,
we
cool,
can in any way.
awesome. Thank you so much.
Sure. And does anyone else have any questions? I think we don't have a lot of people here. But if anyone else has any questions, then go ahead and ask. We have a Braavos channel over at Discord, so I'll we can communicate over there. Okay, so it was nice chatting with you, and have a nice evening or day wherever you are. Bye, everyone.
Thank you.
Thank you.